Okay, well, we're talking today with JoAnne Yates and Craig Murphy, who have written a book called Engineering Rules, Global Standard Setting Since 1880. JoAnne is a Sloan Distinguished Professor of Management at MIT, and Craig is the Betty Freyhof Johnson 44 Professor of Political Science at Wellesley College. And thanks for joining us on the Hagley History Hangout for this. Well, the book title is the first question, Engineering Rules, Global Standard Setting Since 1880. Can you explain what you're talking about in this book and why you use those terms?
Yeah. So our focus is on a particular type of standard setting, voluntary consensus standard setting. So this is not where governments set standards and mandate them. This is where private organizations made up primarily of engineers set standards by sitting down at a table and arguing until they arrive at a standard they can all agree to. And engineers play the major role in this and have for 100 years.
And there's standards for everything. There's standards for the width of the boards behind us, the heights of the windows, the size of our clothing, the electrical current that's going through, the screen size that we have. Almost everything in our built environment that is manufactured conforms to some kind of standard, and most of those standards have been set by little tiny committees of engineers. They are the rules done by engineers.
Now, I think we also intended a slight pun on engineering rules as well.
Engineering rules.
Well, I'm sure that's popular with the engineers.
Yes.
Why do we need engineering rules? Why does this happen, and why does it happen, and why does it happen when it happens?
So we need these standards, these rules, because so much of innovation builds on platforms of standards. You have to have standards that allow an even ground for it, that allow interoperability, that allow things like that, before you can innovate on top of it, before you can have a lot of the new technologies that we want to have. If you don't have, for example, screws and threads that work together across companies, then every single time you lose a screw or strip a screw in some piece of machinery, you have to go back to the original manufacturer. And that's what happened for centuries. There were not ways to have standard screws that always worked with the nuts, the threaded nuts. I mean, this was a problem through both world wars too, where England and the US, for example, had different standards for a lot of screws and threads on airplanes. It caused problems. So it's really important to have standards.
And so many of our technologies, modern technologies, are network technologies,
Right.
where just for the connections of the electrical system or even the railway system, you actually have to have standards to make things go from one place to another. Anyone who's been at the point in Eastern Europe where the old Russian railway system and the European railway system come together, and you have to get off one train or go on to the other, or in some places have the railroad cars lifted from one to another because the Russian tracks are wider, knows that network systems have to have standards.
Have to be interoperable.
So when does this effort to standardize screws, rails, rules of various sorts, when does that emerge?
Yeah. So the type of organizations whose whole mission in life is to set standards, they emerged right around 1900. But in the late 1800s, a lot of engineering societies had been established. We were going through a period of professionalization of engineers. And so they all had established, mechanical engineering societies, all the industrializing countries, and chemical engineering societies, and so on. So as part of the professionalization project, essentially, a lot of those societies thought that one thing they could offer to the world is to help set standards. And so they started setting up committees within their societies to set up standards. And around 1900, a new step was taken, which was to set up organizations that combined people from engineers from different disciplines of engineering coming together and having a sole job of setting standards. No longer engineering societies that also set standards, but organizations that were there solely to set standards. This started in the UK. The first one, the first national level one was in the UK, partly because they wanted to standardize things across their empire at that point. And then they went on from there.
During the First World War, many countries, that's the place where you get the first wave of these national standards setting organizations. The US and German organizations were created at that time, but also in the Netherlands, which was a neutral country. It was a moment when, because of the war effort, even in a neutral country like the Netherlands, there became a sort of national interest that engineers reflected of saying, well, we really have to have an organization that allows all of the industries in our country to work together and create standards in a variety of different fields.
This also aggregated up to an international level very quickly after the national level. In fact, there was the first of the international standards organizations that still exists today, the International Electrotechnical Commission, was founded in what, 1904
or six,
or six, depending on whether you count it by when they first met and agreed to form, or when they
said that we've now formed.
They got people to sign on. But that was dealing with electrotechnical standardization. So right away, I mean, electrical engineering was a new field, but they felt immediately the need, especially across Europe, for example, where electrical wires easily crossed national boundaries, and they immediately saw the need to have standards internationally as well. That happened somewhat in parallel in the early phase, but when international standardizing really took off was not until after World War II.
Yeah.
And that's when it really expanded and became the major direction for standards.
Well, you're talking a lot about the organizations push for standards. You use a term in the book called standardizers.
Yeah.
Tell us something about these standardizers. I mean, I know they're engineers. I got it. But there's a lot of engineers. Who are these standardizers? How do they become standardizers? Talk to us about these agents of change, this force that generates this whole process.
So they were actually, they actually formed a social movement. In the early days, they all felt that setting standards was going to save the world. And they thought it would help bring international peace. It didn't, of course, but they thought it would.
Prosperity, which
prosperity,
it
did more. But they were engineers who were true believers in this idea that any standard is better than no standard, and that it was really important to cut across national lines and industry lines and national lines and agree on things.
And they believed, because they were engineers and therefore scientific, that if they work together patiently and deliberately and with diplomacy, etc., they would always find the best way to do anything. And therefore, the idea of creating standards on the basis of consensus of all of the, what we would now call major stakeholders, or engineers representing the major stakeholders, was the best way to do it.
And they believed, they were very, the people who led the committees and the best standardizers were very diplomatic.
Often multilingual.
And patient, and they didn't, the real leaders of the movement never went for the glory themselves. They always played behind the scenes because they were trying to get everyone else to come to consensus. So, the heroes of standardizing, as you might call them,
They call them that.
yeah, were in fact somewhat on the self-effacing side, and they believed so strongly in the need for this that they were willing to stay in the background to work and get everyone else to agree. So Charles Lemaistre, for example, is our first big figure in this. He came from the Channel Islands.
The little islands between France and England, and he was
bilingual
from, that's
words.
Yeah, from as soon as he started talking. He was an electrical engineer. That meant he worked on, electrical wires and that sort of stuff. And he was maybe the greatest promoter, certainly in the English and French-speaking world, of standardization. He worked tirelessly to go to country after country after country and convince people, that other engineers, that they really needed to devote their time to establishing standards, volunteer their own time. The standards were not only voluntary in the sense that they were adopted voluntarily, a lot of the time spent in these things was done voluntarily. And Lemaistre traveled the world to convince everyone for 50 years that this was a great thing to do.
He was the secretary of the UK national body, but he was also the general secretary of IEC, the International Electrotechnical Commission. And at the very end of his life, after World War II, he was instrumental in setting up ISO, the International Organization for Standardization, that is the peak of the standard system now.
And he was considered a hero in setting up standards, convincing people to set up standards organizations, not only in his own country, supposedly Great Britain, but in France, in Sweden, in the US, in the Soviet Union, basically in every industrial country that he went to, he was considered one of the people who made this system, which is now a global system, possible. And he was honored by the engineers all over the world.
Yeah, and
it's kind of weird.
He was considered the father of standardization by many people. There are two other major figures that we talk about in the book who are also major standardizers who devoted their careers to this. You want to talk about the second one?
Well, the second one is a Swedish engineer who was really the key figure in making the International Organization for Standardization what it became. His name was Olle Styren. It's hilarious that he was actually a modular kitchen engineer. Sort of interesting for it being Swedish. But Styren, like Lemaistre, was multilingual. He was a great internationalist. He was someone who when he was a young man, had been convinced to go to work with the United Nations to try to create a standardization organization in Turkey. And that became he said, well, now, that was so great that we did that for Turkey. We need to do this for the entire world. And he,
particularly the developing world. So,
particularly the developing world.
As head of ISO, as the what was his title?
Executive Director, General Director, Secretary General, probably.
Right. He went to lots of developing countries and helped them set up their own national body that then could be the member for that nation of ISO. So he really pushed the international standardization into the developing world, beyond the industrialized countries into the developing countries.
One of the things as a political scientist that I found interesting about Styren, this is what JoAnne said, is that most of the intergovernmental organizations that work on economic issues that you could think of, that are connected with the UN system, don't have, like the World Bank, don't have great legitimacy in the developing world, even though they do lots of things for the developing world, because they're kind of run by the industrialized countries. Styren made sure that the ISO, this weird thing that is non-governmental, actually has astonishing legitimacy throughout the developing world. And one of the things that was sort of a problem for political scientists is that they could never figure out why that was. Well, because it involved engineers from the developing world from the very beginning.
Yeah. So let me talk about for just a second about a third standardizer who is one of these heroes. And it's someone that you probably know about, but think of as, you don't think of as a standardizer. And that is Tim Berners-Lee, the creator of the World Wide Web. Most people think he's really important because he was the inventor in some sense of the web. But I think what's more important than the original invention of the web was that he then set up a global standardization organization for the web, so that he didn't want it to balkanize, and he was afraid. He gave it away free to the world, but then he thought it would balkanize, so he set up W3C, the World Wide Web Consortium, to be a global standardization body to keep the web standardized and have a base across which the web all worked. So, you know, he's another standardizer who we don't think of. Most people don't think of him primarily as a standardizer, but we think his work as a standardizer was every bit as important as his work as the inventor of the web.
Well, and his ideology was just, you know, he's a British electrical engineer, right? But his ideology and Lemaistre's, if the two of them could have been sitting in the same room together, they would have been on exactly the same wavelength. I mean, they talk about, Berners-Lee talks about how the internet is for everyone, and the internet is going to create a peaceful world, and the internet, you know, or the web is going to do all of these things. And you could see, Lemaistre would be sitting there going, electricity was, all of our standards are going to do that. And they both were believers in the idea of engineers being able to sit down together and reach consensus on something that's kind of like the one best way to do things.
Well, let me ask you about another standardizer in your book. There's this fellow by the name of Ralph Showers who comes in there.
Yes.
I bring him up because one of the generous things you did out of your project was lead us the Hagley Library to Showers. But talk about Showers and his role in this process.
Okay. So first, let me just say something about the difficulties that we encountered doing our archival work. It turned out that almost no archives have traditionally collected standardization documents. So we ended up having to follow individuals down a path. And Ralph Showers was someone whose name we were given by engineers. He was still alive when we were given his name originally, and we tried to set up an interview with him, but he died before we could do that. But his daughters actually gave us access to 200 boxes worth of his records at their home. And much to our relief, we got Hagley to take these records after we looked at them in their home. So they are now in the best possible place they could be for access by all of us. So future scholars can see these documents because they are at Hagley. So Ralph Showers was just this fascinating guy. And luckily, because we also were able to interview the daughters, and they sent us a lot of private stuff, family stuff as well. We got a pretty full view of him. He was a standardizer in the area of what was originally called radio frequency interference, and then later was shifted to be called electromagnetic compatibility, EMC. These are the people who, you know, initially set standards that would keep cars from interfering with your radio inside the house, or your TV inside the house, or microwaves from interfering with the TV. And now, I mean, they are absolutely central to so much of technology today, but you know, it's a very obscure area. No one knows about this EMC area except the people in it.
And mostly because, I mean, those of us who are as old as JoAnne and I are, know about this area because we used to have to play with the rabbit ears on the television set to make it work. But the standardization works so well that we don't have much radio electromagnetic interference. And Showers is a guy who started in this work in World War II and became central to the major committee that has done this work from that period onward.
And not just one committee. So there's a whole layering of committees up. So he was the head of, C63, Committee 63 of the U.S. National System, the ANSI, what's now ANSI system. But he also was the head of CISPR, which was a European-based originally. It became a special committee of IEC, the International Electrotechnical Commission, and he was the major person on
and that really has become the global organization.
Right. And then in ISO, he's the major figure was the major figure until he died on that. And he was, people talked about him as the Energizer Bunny. He just kept going. And he had infinite patience to keep working, going back to the table. If everyone didn't agree, they would not go for a standard that didn't have a universal agreement, that if anyone objected, they wouldn't go forward with it. So he would ballot every time, versions of this there was one particular standard, they went through 11 different ballot versions that they balloted. And even on the 11th version, they had to go through 4 little sub-ballotings on that before they got agreement. But he had the patience to just keep doing that and to keep writing up what the objections were and how they could get past them, and doing that was critical. He was also the person who helped, coming out of World War II, the US was not used to playing in international standards. They thought that they could set standards for the US and that was all that was needed. And they were the major country, so why should they bother with
especially right after the war.
Yeah, they were feeling very good about themselves. So he actually was the one who helped US become a player in the international EMC standardization, and he was the first American to be the head of CISPR and then of the IEC versions of this and the ISO versions. So he really was the one who guided the US engineers in this area into the international arena.
And like, in a sense, like the other people we've mentioned, he was a very, very good engineer. His day job was to be on the faculty at Penn. Right. He was a very good engineer. He was an incredibly good diplomat. Even though he was an American, he was well loved by people all over the world because he was capable of, putting himself down and being modest and quiet and all of those sorts of things. And he could deal with things like the representatives of the American auto industry, who were sometimes loud and boisterous in one way or another, and also deal with them quite well. And he was patient and meticulous. Yeah,
he was patient and meticulous, and he just did his work, and he made a huge difference in an area that most people aren't aware of. But without this area and without standards in this area, there's so much that wouldn't work in our world today. This is really what keeps our world functioning. So, having our computers not interfere with our other devices, for example, they're the ones who do that. So, it's pretty important.
You could say that we wouldn't be able to have this conversation on Zoom without a lot of standards.
That's for sure.
Start off with electricity,
yes,
that we're relying upon, but also signal and wavelengths and other kinds of communications, the interference and all those other things like that.
That's right.
I want to ask you a little bit more about this, the difficulty of sources, because standards are one of those features of our world which we literally take for granted. In a way, the whole point of a standard is to be taken for granted, so that when you want to replace, when a bolt falls out of your computer and you need to replace it with another bolt, you could just go to the hardware store and replace it. And it's nothing more than just finding the right width and it goes in there. Compared to having to contract with a local machine shop, to
Right.
recreate what you lost. So in terms of visibility or invisibility, how else did you go about researching it? You have the Showers papers. That seems obviously a great find, but how did this invisibility, how did you get around this invisibility issue in your research?
So we did have that. We did go to ANSI headquarters in New York. ANSI is the American National Standards Institute. They told us they had no records, but then
as ISO told the International Organization for Standardization, they said we have no records. Those are the records are kept by the member organizations.
But when you get there, they had some records at the centralized level, but then they would each send you down another level. So from the international to the national to the IEEE, for example, they'd send you to IEEE, or they'd send you to C63, the Electromagnetic Compatibility Committee, and then to people. So so we did use both the ISO records and the IEC records. We used Craig and some students went to Sweden to get personal records that Ole Sturen had,
and convinced the family of Ole Sturen to give those records to the Swedish National Standards Institute, which came up with this crazy idea that maybe they needed to have an archive and collect records on a lot of things of that sort. So that was actually quite exciting to watch that happen.
In a few cases, we found bits of stuff about standardization in the papers of people that were in an archive for another reason. So your guy at Haverford.
Yes, whose name I'm now.
That's all right. So one standardizer whose records were at Haverford for other reasons had some stuff, and at the Stanford archives, I had an individual's records that included some ITU standardization records. Now that's an intergovernmental, not a voluntary private one.
And we found some of
those.
They
intersect.
Yeah, we found some of those at the University of Glasgow, for example, and at the Swedish or the Swiss National Archives.
Right.
Again, it's this sort of weird thing finding the engineers' records there for other places.
Yeah, but I felt like I had hit the mother lode when I found these 200 boxes of records from Showers. That his attic and his basement were full of these things, and I didn't go through by any means all of them. I mean, I had a relatively limited time, and I focused in on the things I knew I was interested in, and there's much more to be found in those records, which are on deposit now at Hagley. The other collection, the current head of C63, the same committee, Dan Houlihan, was collecting papers and digitizing them to keep the history of that organization internally, and he didn't care about the documents themselves. He wanted them all digitized. So when he finished digitizing the records of Leonard Thomas, who had been ahead of that at one point, he literally shipped 3 boxes worth of documents to me. At the time, I was at Stanford for a year on sabbatical doing research at the Center for Advanced Study in the Behavioral Sciences. So I got these 3 big boxes of original documents, and those also are on their way to Hagley. I'm still taking out the Post-it flags I put on. Actually, they would be at Hagley now if it weren't for the COVID. Things have slowed down because of that. I figured no one was going to do anything with them during this period. So,
one thing which you're saying by its absence is you didn't find corporate records useful.
No, that's really interesting. Yeah.
So that's interesting. The individuals who served on these committees, some of the engineers were from corporations, but the corporate records, we at least didn't find any. Now, I'm not sure that they don't exist. And, by the end, we had so much material, and there was so much big a story to tell with what we had that at some point we just had to stop. But I'm not convinced that if you go deep enough into some corporate records, you might not be able to find some. So, for example, the ICA records. I think if I spent enough time delving into them, RCA was very involved in the, the color TV standards and the black and white TV standards. And I suspect that depending on what was saved, there might be some information there. But this is not stuff that's going to be talked about at the very top of RCA. It's going to be something happening in a sort of middle level, and it would take a lot of search. So, we didn't actually find an easy way in through corporate archives.
Yeah, and that was actually one of the sort of fascinating things at the beginning, was to realize, and it was one of the things that helped us understand that what we were looking at was this network or community of engineers that was truly transnational. Even if most of the people sitting on these committees, when they're sitting there, are people who are working for a particular company, and the company has an interest in them being on the committee. The way the kind of system works is they thought of themselves as the standardizer, to go back to that word, and the records therefore got aggregated as their own records, which would not necessarily be things that would then appear in a corporate archive, because they're not important, important enough to be a person supposedly to have their things in the corporate archive.
And let me give you one example again from the electromagnetic compatibility records that we got access to from the Leonard Thomas papers and the Ralph Showers papers. You get these reports that are from the people from the auto industry who were involved in electromagnetic compatibility around autos, right? So there was a guy from Delco who was the representative of the Society of Automotive Engineers. Yeah, and we have all of his reports that he turned into the organization, and the reports of the person before him. I've forgotten which company he was from, but he was temperamentally horribly badly suited to standardizing. He was absolutely sure that the American way was the only way, and he had no interest in doing anything but enforcing the will of his point of view on the Europeans. And so he got nowhere, and he finally resigned. And then this guy from Delco came in, and he came to learn from Ralph Showers and others how important the diplomatic level was. And so he worked very hard, and over a long period of time achieved a lot. And they did some of the testing for some of these at the Delco testing facilities. So there is an intersection with companies, but we're finding the documents more through the standards than through the company. Now, I actually don't know if Delco has records, and maybe had we gone there too, we might have found something, but I don't know that we would have. I mean, it's not a high level decision, and it's not high level stuff. It's sort of mid-level engineering.
Well, one thing that was so interesting about that, JoAnne, is that those records were not with the companies, which meant the companies did not claim that they had to have those records, that the records were generated and therefore should be in the possession of the company.
Right.
And that's fascinating by itself, because as you know, we have a lot to do with DuPont, where we are, and you don't find DuPont people leaving and taking those records with them. That's just not what you do these days. The records are it's called intellectual property law, and that property belongs to the firm. In this case, for reasons that I think have to do with your cohort, your standardizers, it seems that firms accept that these records belong elsewhere, which allows you to trace that whole process, which itself is a very interesting dynamic in 20th century capitalism, to have that, if you will, an exception, a very large exception to corporate control over the activities of their employees.
Yeah.
So
that's right.
One of the examples of this is to go back to those records that we found at Haverford. So his Murray Freeman?
Murray Freeman, yeah.
So Murray Freeman worked for Bell Labs. He was one of the people who created Fortran, the language. And Bell Labs didn't want his records. Lucent, thought because what he spent most of his time doing, yes, they wanted his stuff about software creation, but he had all these other records that were about the standardization across networks. It's kind of early internet stuff, right, that he had been doing from the 1970s onward. Not only did Lucent not make a claim to them in any way, there was this sort of sense, oh, that would just take up space. That it's not something that was of any interest. His alma mater, Haverford, whose librarian happened to have previously been at Hagley, under the division there, they figured, Murray Freeman is a Haverford graduate who kind of invented something fairly important like Fortran. Maybe we really wanted his records, and that was great, because that it's nice that there was another place where such records would appear.
That's fascinating. Well, let me start closing this up here and ask you a broad question. Suppose someone's read your book, they listen to this interview, the scales have fallen from their eyes, and they see the importance of standards. Suggest some vectors for further research that you'd encourage a graduate student, someone who wants to develop more this idea of standards, and what directions are there?
Yeah. So I think there's a lot to be done in looking at standards within particular domains. We dipped in and out of a few domains, but there are many domains where there's a lot of interesting stuff around standard setting, and where the social dynamics and the political dynamics and so on are quite interesting. So, anything internet related, if you dig deep enough, and those the IETF, the Internet Electrotechnical
Engineering Task Force,
sorry, the
Internet Engineering Task Force,
right? IETF is its records are all online and available, so you can get those, and the W3C, and you can go in and look at one particular development and get all the back and forth and discussion that went on to set those standards. So within specific domains, I think there's fascinating stories.
Aircraft is another place that we go. All the civil aviation stuff was huge, but we didn't, just touch the very surface of it.
Yeah. So there's many areas, specific domains that so for a doctoral student, I think that's a great way to go. And it intersects, for example, in Lee Vinsel's recent book, Moving Violations, about the auto and regulation, he defines regulation broadly and talks not just about governmental regulation, but also about standards at some point, and standard setting. So it intersects with things like regulation in certain areas. So, that's a great example also.
So two things that I would mention. One is the way in which, because of the things Ole Sterin did of opening up the standardization system to the entire developing world, there's a way in which a lot of the people who are involved in standard setting from parts of the developing world also became key people in innovation within the technological areas of their particular country, as in the case of Turkey, or in Brazil, or in India, which is actually a really big deal. Maybe in China, although that's a much harder story to figure out. And there are lots of dissertations there. And then the one thing that both of us noticed as we finished the book, there's a whole story about gender and race that we didn't talk about.
We talked at the very end.
But there's a way in which the standardization story, I mean, it sounds like it's wonderful and transnational and all of this sort of stuff, but until very recently, it was mostly a white guy's story.
Yeah.
And trying to figure out both the ways in which the engineering profession globally had sort of barriers to entry to different groups. And then what's been happening since the 1980s, when those barriers have started to fall down in a variety of ways, is absolutely fascinating. And it's a book, I mean, if that would be the next book, if I were wanted to do on standards, that would be the one.
And how the developing world has gotten more involved in some of these is part of that as well. So it's diversity on a whole slew of dimensions, you know, gender, race, but nationality and all kinds of areas. So there's huge stories to be told there.
Well, there you go. Great project, great research directions. I'm sure reading more. I hope people go and take a look at your book.
And I hope so too. If I could just for a second. I think Johns Hopkins Press did a fabulous job on our cover, so I have to show the screw and bolt that they created.
Someone actually created a cover that was more than just a picture.
That's right. That's right.
Well, thank you very much. We'll end our recording. Hang on.
Thank you very much.